MS Ramaya University of Applied Sciences.
Diffraction grating. Hello students, let us discuss the determination of the grating constant of the given diffraction grating and calculate the wavelengths of the prominent lines in the mercury spectrum by minimum deviation method. First, let me discuss the theory behind the experiment. Diffraction is the bending of light around the corners of a sharp obstacle. It is observed only when the width of the slit is comparable to the wavelength of the light used. A diffraction grating is a plain glass plate on which rulings are drawn with a sharp diamond pin. The rulings correspond to opaque regions while the region between two successive rulings is transparent. It is an arrangement of multiple slits. The regions between two successive ruling acts as slits and the distance between corresponding points of two consecutive slits is known as grating constant. In this experiment, light from mercury source passes through the grating and the spectrum is viewed using a spectrometer in minimum deviation method. There is a certain angle of incidence for which the deviation of light produced by the grating has a minimum value. When this condition exists, the grating is said to be in a minimum deviation position. In this minimum deviation position, wavelength of the spectral lines can be calculated by measuring the angle of minimum deviation for all the spectral lines. Grating constant can be calculated by measuring the angle of minimum deviation for green line and knowing the wavelength of the green line.
Hello students, in this experiment we determine the grating constant of a given diffraction grating and determine the wavelength of prominent spectral lines in mercury spectrum by minimum deviation method. The apparatus required to conduct this experiment are mercury vapor lamp, spectrometer which has got collimator with a narrow slit at one end, telescope, grating table on which we are mounting the grating, circular scale which has main scale and the vernier scale, a diffraction grating which has got large number of lines ruled on it, approximately 15,000 lines per inch, which is equivalent to large number of equidistant parallel slits, a spirit level to check the leveling of the grating table, magnifier and the lamp to record the readings. Condition for diffraction of light is that the size of the obstacle should be comparable to the wavelength of the light used. Since the diffraction grating has got large number of lines, approximately 15,000 lines per inch, the distance between the lines is comparable to the wavelength of the light used and hence the light undergoes diffraction when it passes through the diffraction grating. The diffraction of light through the grating is equivalent to Fraunhofer diffraction due to multiple slits. The spectrum obtained here is a grating spectrum. The exact position of the principal maxima in the diffraction pattern depends upon the wavelength. The principal maxima corresponding to different spectral lines corresponding to the mercury spectrum corresponds to different angles of diffraction. The angle of diffraction corresponding to different spectral lines will be measured in this experiment by keeping the grating in minimum deviation position. Let us start the experiment. First, we have to do the initial adjustments of the spectrometer. First, focus the telescope towards the white wall. Work on the eyepiece so that the cross wires are seen clearly in the field of view. Next, focus the telescope on any distant object. Looking through the eyepiece, work on the tangential screw of the telescope till the image of the distant object is seen clearly in the field of view. This adjustment of the telescope sets the telescope to receive the parallel rays. Care should be taken to see that the tangential screw should not be disturbed throughout the experiment. Next, the spectrometer is moved towards the mercury vapor lamp and the collimator is adjusted to the source. Bring the telescope in line with the collimator. Look through the eyepiece. You will observe a wide and a blur image of the slit. Next, looking through the eyepiece, work on the screw attached to the slit till the width of the slit is as narrow as possible. After that, work on the tangential screw attached to the collimator. Work on it till a bright, intense slit is observed in the field of view. This adjustment of the collimator sets the collimator to receive the parallel rays from the source. The image of the slit in the field of view of the telescope is due to the direct ray from the source. Next, we have to check whether the grating table is leveled. For that, place the spirit level on the grating table. See whether the bubble in the spirit level is at the center. If it is at the center, it ensures that the grating table is leveled. If not, there are 3 leveling screws which are provided at the base of the grating table. Work on the 3 screws simultaneously so that the bubble comes to the center, ensuring leveling of the grating table. Next, mount the grating on the grating stand and fix the grating table. Now, light from the source passes through the collimator, falls on the grating, undergoes diffraction. And the characteristic spectrum of the mercury can be viewed through the telescope. Look through the eyepiece of the telescope. You will be able to see the slit which is due to the direct ray. Turn the telescope either towards right or left till the characteristic spectrum of mercury consisting of the prominent lines violet 1, violet 2, blue, bluish green, green, yellow 1 and yellow 2 lines are observed in the field of view. Fix the telescope with a vertical cross wire near to the green line. Now, set the grating for minimum deviation. For that, looking through the eyepiece, turn the grating table either clockwise or anti-clockwise so that the green line in the field of view moves towards the incident ray. Continue turning the grating table until the green line moves towards the incident ray, stops, then retraces its path. This position is the minimum deviation position. Fix the telescope at this minimum deviation position by turning the screw which is below the telescope. Now, looking through the eyepiece, work on the tangential screw fixed to the base of the telescope. Your cross wire moves. Now fix the vertical cross wire exactly on the LO1 line. Reading corresponding to the LO1 line can be recorded by noting down the values in the main scale and the vernier scale. Use the magnifier, switch on the lamp, record the main scale reading and the coinciding vernier division. Next, again the tangential screw is rotated till the vertical cross wire now coincides with the LO2 line. Again, the reading corresponding to LO2 line is recorded by noting the readings in the main scale and the vernier scale. This procedure is repeated by coinciding the vertical cross wire to the green line, bluish green line, blue line, violet 1 and violet 2 lines. Next, move the telescope such that it is in line with the collimator. Now we can observe the direct ray. Fix the telescope, work on the tangential screw such that the vertical cross wire is exactly coinciding with the direct ray. Record the reading of the direct ray by noting down the main scale reading and the vernier reading. From the values recorded for various spectral lines and the value corresponding to the direct ray, the angle of minimum deviation corresponding to different spectral lines can be determined. From the angle of minimum deviation corresponding to the green line and knowing the wavelength of the green line, the grating constant of the diffraction grating can be determined. From the value of grating constant and using the angle of minimum deviation for other spectral lines, the wavelength of all the spectral lines observed in the mercury spectrum can be measured.
At MSR UAS, we spark your imagination unlike any other.